The dramatic story of the fighter plane is one of the most colorful episodes in military history. Barely 10 years after the invention of the airplane, the fledgling fighter saw combat action in the First World War. Between the wars, the American aircraft industry expanded and development in fighters continued. World War II saw U.S. air power play a major role in the defeat of Nazi Germany and Japan. The world's first jet war over Korea pitted American jets against Soviet-built MiG-15s. In Vietnam, the major threat to U.S. air supremacy were SAMs, or surface-to-air missiles, rather than enemy fighters. Complete control of the air over Iraq by U.S. and coalition air forces made possible the 100-hour ground war, decisive victory in Desert Storm. To the very ultimate in fighter technology, at 2 times the capability of today's top-of-the-line fighters, the advanced tactical fighter, a fighter of the 21st century. The Second World War and the recent conflict in the Persian Gulf have made perfectly clear the absolute necessity of air superiority in gaining the military victory. With that in mind, the U.S. Air Force and the U.S. Navy in 1986 awarded 2 preliminary competing contracts for the 21st Century Fighter, officially designated the Advanced Tactical Fighter, or the ATF, a totally awesome combat aircraft with twice the capability and power of today's top-of-the-line fighters, vigorously competing for the title in some $64 billion worth of production contracts with 2 consortiums made up of the giants of the U.S. aerospace industry, as well as the 2 leading aircraft engine manufacturers, General Electric and Pratt & Whitney. On one side was the team consisting of Lockheed, Boeing, and General Dynamics. Opposing them was Northrop and McDonnell Douglas. Under $818 million contracts each to design, produce, and flight test, each team has manufactured 2 prototypes. The Lockheed Group has created the YF-22 and the Northrop team the YF-23. One each of the YF-22s and YF-23s is powered by twin GE F-120 jet engines, and the others by the P&W F-119 jets. Before the dawn of the 21st century, at least one of these super air fighters will obsolete today's great U.S. battle planes, our Air Force's F-15 Eagle and F-16 Fighting Falcon, the Navy's F-14 Tomcat, and the Fa-18 Hornet, and the best of the Soviet fighters, the MiG-29 Fulcrum and Su-27 Flanker.
It was just about a year ago, May 15th, as a matter of fact, of last year, that the Department of Defense and the Air Force first unveiled the two specification drawings of the two candidate aircraft for the Air Force Advanced Tactical Fighter, a program which Secretary Cheney thinks is vital if the United States is to maintain air superiority, which is an unquestioned priority for the Air Force and the Department of Defense.
To further reinforce the need for the Advanced Tactical Fighter,
how bad does the country need a plane? Let me ask you something. Do you have a brother? You have a sister? You have some people that were over in Saudi Arabia?
No, sir.
No, you don't. Well, a lot of other people do. How many of those would you like to see them come back in body bags? Not very many of them came back. And the reason they didn't come back is because we ruled the air. If we hadn't ruled the air, then we couldn't have bummed those people into the submission we did. Now, you want to take a risk on that for your kids? You got kids? No, you don't have kids either. Well, a lot of people do. And those kids are what's going to be fighting the next war. So we have two choices. We can either ensure air superiority, and when I'm talking about air superiority, I am not talking about parity. That is not air superiority. We do not get to choose the time of the war or the place of the war. And we may not be as fortunate that we've got 6 months to build up to get all our forces in place. So when the war starts, I've got to have a superior airplane, and I do mean superior, if you want to control the air. If you do not have that, then gentlemen, you just look at what happened to the Iraqis, and you can just count that's what will happen to us. Now, who wants to take that issue on? That's the fundamental problem. We have proven that the technology is here. We have proven that we have the requirements in hand, and we need to take this next step. If you want to guarantee our capability to exercise our national will in the year 2000 and beyond. At that time, the F-15, we will start retiring them because they are running out of life. They will have been in service over 25 years. You want to put your sons and daughters out there flying them? That's a real question. And I don't mean to get emotional on you, but that's what we're talking about. We're talking about those kinds of judgments.
while the U.S. aircraft industry has produced the greatest air superiority fighters, starting with the North American Aviation P-51 Mustang in World War II, this has not always been the case. When the U.S. entered the First World War in 1917, we were relatively unprepared. Despite the fact that the airplane was invented in Dayton, Ohio by the Wright brothers, Wilbur and Orville, who first flew in 1903 over the sand dunes of Kitty Hawk, North Carolina, and although the Wrights produced the world's first military aircraft for the U.S. Army in 1908, not a single American-built or designed fighter plane flew or fought in World War I. Before the U.S. entered the war, American volunteers in the French Lafayette Escadrille flew the early French Nieuport Scouts, models 11 and 17. As mentioned, the first fighters were called Scouts because they were originally employed for reconnaissance. 2 years later, when the U.S. entered the war, fledgling American Air Service pilots flew French Nieuport 28s and SPAD 13s. Here we see America's First World War ace of aces, Captain Eddie Rickenbacker and his 94th Hat-in-the-Ring Aero Squadron. Other American aces, like Lieutenant George Vaughan and Captain Elliot Whitesprings, who trained and fought and flew with the British Royal Air Force and the predecessor Royal Flying Corps, flew the legendary British Sopwith Camel and SE-5. With the armistice, the infant American aircraft industry did get down to brass tacks and produce some great fighters during the peacetime years of the 1920s and 30s. Among those were the Grumman F-2F and F-3F Navy fighters, the early Curtiss P-1, 3, 5, and 6 Army planes, and Boeing, who we know today as the great builder of multi-engine bombers and great civilian airliners, built the classic Army P-12 and Navy F-4B-4 and the revolutionary first all-metal low-wing monoplane fighter produced in quantity, the P-26 Pea-Shooter. The P stood for pursuit. The Scouts were now pursuit planes. They kept that title until after the Second World War, at which time they were designated F for fighter, which remains to this day. The U.S. entered World War II with the Army Curtiss P-40 Warhawk, made famous by the Flying Tigers, and the Navy Grumman F-4F Wildcat. To better counter the Japanese Zero, Grumman brought out the improved F-6F Hellcat, which fought alongside the Vought F-4U Corsair. Best of the Army Air Force fighters were the Republic P-47 Thunderbolt, Lockheed P-38 Lightning, and topped by the great North American aviation P-51 Mustang. 1950 saw the outbreak of the Korean War, the world's first jet war. North American aviation F-86 Sabre jets tangled with Russian-built MiG-15s over the 38th parallel and beat them to the tune of 10-1. Navy jets included the McDonnell F-2H Banshee and Grumman F-9F Panther, the first carrier jet to shoot down a MiG-15. American arms were tested once again over Vietnam in the mid-1960s and 70s. The principal American fighter was the American Douglas F-4 Phantom II, which was the mainstay of both the Air Force and the Navy. Few North Vietnamese MiG-17s, 19s, and 21s went aloft to challenge the U.S. forces, and Phantoms and Republic F-105 Thunder Chiefs ruled the sky. A short incursion into Panama before Christmas 1989 to oust the dictator drug dealer General Manuel Noriega saw the baptism of fire of the till-then top-secret U.S. Air Force Lockheed F-117A stealth fighter. A little more than a year later, early on 17 January 91, an F-117 stealth dropped the first bomb of Operation Desert Storm in the Persian Gulf War. That 2,000-pound Paveway smart bomb accurately destroyed the Iraqi Air Force headquarters in Baghdad. The stealth was joined by Air Force McDonnell Douglas F-15 Eagle and Strike Eagle air superiority fighters, General Dynamics F-16 Fighting Falcons, Republic A-10 Thunderbolt II tank busters, and Navy Grumman F-14 Tomcats, McDonnell Douglas F-A-18 Hornets, and Harrier jump jets, and Grumman A-6 Intruders, along with Army AH-64 Apache and Army and Marine AH-1 Cobra choppers. As in Vietnam, not many Iraqi fighters accepted the challenge or rose to do battle. Those that did, Russian-built MiGs and French-built Mirage F-1s, fell before coalition air forces' air-to-air missiles. The rest of the enemy air force hid or fled to neutral Iran. Following a 100-hour ground war, the ceasefire took place on 28 February 91. Our Desert Storm aircraft are the fighters we have today. But what about tomorrow, the future, the 21st century?
I'd like to talk for a moment about why we're developing a new fighter at this time. There's probably not a person in this room or in the reach of your television cameras who isn't aware of the contribution of stealth to our success in Desert Storm. In that case, it was a bombing capability that we were seeing in action. But the principle will apply to both ground attack and air-to-air missions in the future. The ATF is intended to replace the aging F-15 Eagle, currently our frontline fighter. The Air Force's F-15s are outstanding aircraft, and they swept the skies in Desert Storm. However, when the ATF is first deployed, the F-15s will be over 25 years old. Several other aircraft, including some we faced in Desert Storm, are aerodynamically competitive today with the F-15 and other leading U.S. fighters. We win today with an edge in avionics and by relying on the superior skill and training of our pilots. Others will try to close that gap between now and the year 2002, when the first ATF squadron is fielded. The ATF will balance stealth, supercruise, and advanced avionics in a highly maneuverable fighter that will ensure that our pilots get first look and first kill. Thus, the ATF will ensure American air superiority well into the next century. As we have seen in Desert Storm, air superiority is essential to effective air and ground operations. American ground forces have not had to fight without air superiority since 1942, and we plan to keep it that way as well.
The Advanced Tactical Fighter, or ATF, is being developed to counter the increasing sophistication and threat of hostile air superiority forces around the world. This fighter will provide air superiority for the tactical air forces in the late 1990s and well into the 21st century. The F-15 Eagle entered the Air Force inventory in 1975. The F-14 Tomcats joined the Navy about the same time. Threats which the F-15 and F-14 can no longer counter will be defeated by the lethal and survivable ATF, with its balance of increased speed and range, enhanced offensive and defensive avionics, and reduced observability. Emphasis on reliability, maintainability, and other effectiveness factors will keep the fighter flying in the harshest combat conditions with quick combat servicing. The increased logistics, supportability engineered into the ATF means fewer resources will need to be committed for each ATF squadron at forward locations. The U.S. Air Force manages the program through the ATF Systems Program Office at the Air Force System Command's Aeronautical Systems Division at Wright-Patterson Air Force Base in Ohio. Because of the work done at the Wright Laboratory located there, the ATF features new advanced technologies never seen before on one weapon system. Its 4 S's, stealth, survivability, supersonic cruise, and supportability, are ensured because of the pioneering work of the laboratories. Development of the ATF prototypes will prove the ability of new technologies to enable the Air Force to satisfy operational requirements of Tactical Air Command, thus maintaining our technological edge in air superiority. The Navy has also participated in the Demonstration Validation, or DEMVAL program, to develop a Navy variant called the NATF, or Navy Advanced Tactical Fighter, suitable for deployment from aircraft carriers to replace the formidable F-14 Tomcat. The services are taking advantage of the resulting opportunities to share design elements where the differing Air Force and Navy missions permit. For example, the services are seeking commonality in engines, avionics, materials, and subsystems. The ATF will fly and fight in the advanced radar networks and dense surface-to-air missile environments of combat throughout the world. It will use a first look, first shot, first kill capability to detect and destroy enemy fighters of today and tomorrow. As stated earlier, Lockheed's prototype is designated the YF-22A. Northrop's is the YF-23A. Two prototype air vehicles, or PAVs, have been produced by each contractor team for a total of 4. It is interesting to note that the Northrop entry bears a U.S. Air Force serial number, while the Lockheed model has a civilian registration. This, of course, had no bearing on the final decision. One prototype air vehicle from each weapons system contractor team is equipped with 2 YF-119 engines and the other 2 YF-120 engines, 4 airframe engine combinations in all. Each team has expertise in stealth technology, Lockheed being the manufacturer of the F-117A stealth fighter that proved itself so effective in Operation Desert Storm, and Northrop is the producer of the B-2 stealth bomber. In addition, through the years, each consortium has manufactured a long, impressive list of great fighting aircraft. Lockheed made the P-38 Lightning of World War II fame, and the F-80 Shooting Star, America's first jet fighter for the Korean War, along with the C-130 Hercules and giant transports, the C-141 Starlifter and C-5 Galaxy, and the super reconnaissance spy planes, the U-2, TR-1, and SR-71. General Dynamics created the great compact multi-role F-16 Fighting Falcon, the F-111 Tactical Strike Aircraft, and the World War II Liberator Heavy Bomber. Boeing gave us the great heavy bomber series, ranging from the B-17 Flying Fortress and B-29 Super Fortress of the Second World War, to the aging B-52 Stratofortress that performed so well in Operation Desert Storm, and the KC-135 tanker. And going back to the 20s, when Boeing built the U.S. Navy's F-4B-4 biplane fighters and the U.S. Army Air Service's P-12 and the classic P-26 Peashooter, the first low-wing metal monoplane fighter. Partner General Dynamics produced the Delta Wing F-102 and F-106. The competing contractor team can claim the Northrop P-61 Black Widow night fighter of the Second World War and the F-5 Freedom Fighter of Vietnam fame. And McDonnell Douglas has manufactured today's F-15 Eagle Air superiority fighter and the predecessor Air Force and Navy F-4 Phantom that ruled the skies over Vietnam. The amazing AV-8B Harrier vertical short takeoff and landing attack aircraft, the U.S. Navy and Marine Corps F-A-18 Hornet strike fighter, and the venerable A-1 Sky Raider, affectionately called the SPAD in Vietnam, and the Douglas A-4 Skyhawk, which also saw combat in Operation Desert Storm with the Free Kuwaiti Air Force. And Douglas also produced the classic DC-3 airliner, which served in World War II as the C-47, and today's triple-jet DC-10, the U.S. Air Force's KC-10 tanker. and the new C-17 cargo transport, which can land large payloads on remote airstrips around the world. Reliability and maintainability have joined the traditional factors of cost, schedule, and operational performance when we measure the success of a weapons system. The Advanced Tactical Fighter Development Team seeks to double the reliability of today's best fighters and to simplify the maintenance workload of ground crews. These goals promise reduced manpower and logistics requirements and fewer airlift sorties to equip and maintain forward-based ATFs. The ATF features increased survivability made possible by its use of reduced observable or stealth technologies and advanced sensors. It is also highly maneuverable and cruises at supersonic speeds without the use of afterburners, factors which give the ATF the edge over traditionally designed fighters. The powerful combination of speed and stealth will substantially reduce the surface-to-air missile threat to the ATF, as clearly shown in the chart, while today's F-15 and F-16 will face a practically insurmountable barrier. As for lethality, we are talking about first look, first shot, and first kill. Today's F-16 is the equivalent of the Soviet MiG-29 Fulcrum, and the F-15 is a match for their Su-27 flanker. On the other hand, the ATF can engage today's top Soviet fighter long before the Su-27 even knows he's there, and the ATF will have a considerable edge over the Soviet stealthy advanced threat fighter currently under development. Also, along with the F-16 Falcon, the F-117A and B-2 stealth fighter and bomber, the 21st century fighter shares the amazing fly-by-wire control system, which allows the pilot to command the aircraft totally through a system of electrical wires rather than conventional, complex mechanical systems with pulleys, linkages, and push rods. This new generation of avionics is one of the factors that allows a single ATF pilot to handle the heavy workload of a two-man fighter crew. Today's F-15 Eagle and F-14 Tomcat air superiority fighters, the F-A-18D Hornet, and the Vietnam War era F-4 Phantom require two men to do the job. Designers of ATF avionics are also using technologies such as VHSIC, or Very High-Speed Integrated Circuits, in the development of advanced data processors. These VHSIC chips offer three main advantages over conventional integrated circuits: dramatic increases in both processing speed and power and smaller size. One chip does the work of thousands of transistors. These advanced data processors are assembled in highly integrated common modules linked by high-speed data buses to maximize aircraft performance and minimize pilot workload. The ATF avionics system makes traditional black box systems obsolete. ATF avionics are augmented by technologies such as the Integrated Electronic Warfare System, Integrated Communications, Navigation, Identification Avionics, shared antenna for several avionics systems, and cockpit displays that show integrated data from not one but several sensor systems. ATF avionics software is being designed and written in the U.S. Department of Defense standard computer language known as ADA or ADA. In 1987, at the direction of the Congress and the Office of the Secretary of Defense, the military services launched an ambitious avionics standardization. The Joint Integrated Avionics Working Group task is to develop common avionics specifications and use them in aircraft delivered in the late 90s and beyond. The Joint Integrated Avionics Working Group was assembled from the program offices of the ATF, the Army Light Helicopter, the Navy A-12, and agencies developing variants of these aircraft. The group's strategy is to focus on avionics modules commonality so that users can, to a great extent, use a single avionics inventory. The Joint Integrated Avionics Working Group is balancing the economic advantages of common avionics with the need of tailored systems, and their interfaces with the aircraft itself are included in the effort. The very first prototype ATF to fly was Northrop's YF-23, which on 27 August 1990 was airborne for 50 minutes. Powered by twin Pratt & Whitney YF-119 prototype jets, it climbed to 25,000 feet. Test pilot Paul Metz was very pleased.
At brake release, the pilot comes right up to military power. Very smooth increase in RPM and a very decided push down the runway. Approaching about 120 knots, you apply aft stick and the nose comes up very smoothly. You'll sit on the mains for just a few seconds and then lift off. Once you're airborne, it's a real rocket. It begins climbing very rapidly, even in military power. Right off the bat, it was obvious from the minute I lifted off the ground, we had something special here.
Okay, I've got Ghost 5 up loud and clear and radar contact.
It flies with the best of the best in terms of handling qualities.
It's just solid as a rock out here, Paul. Feels good here.
The first landing that you make in an airplane is the one that you worry about the most at night before you ever do it. It turns out that the YF-23, there's no demanding part of the landing. Coming down final approach, the merest suggestion of requirement to change your speed, and the airplane responds instantly. It rides through the bumps and the turbulence smooth as silk, and the flight control system is to credit for that. The actual flare and landing touches down like a feather. This airplane, I believe, has the capability of having over 6,000 individual parameters monitored. I kind of stopped short of measuring my heartbeat, but outside of that, just about everything in the airplane is measured, monitored, and either relayed back to the ground control station through a telemetry system very similar to what we use in the Space Shuttle program, or recorded on board in a magnetic tape system that's on the airplane. So we know how this airplane lives, breathes, and works for us every second and microsecond that it's airborne. First few flights, the data shows that we're meeting the predictions very well. Nimble and quick like a cat. That's the first impression that I had from the moment I got the airplane up. Two instances come to mind. I can remember distinctly the chase pilots having to go to afterburner to stay with me with my landing gear down, their landing gear up, and I'm not even using afterburner. The other instance was during some low-speed maneuvering performance testing that didn't seem particularly usual to me until later when discussing with the test pilots in the two chase airplanes. They tried to use afterburner to stay with me in the low-speed conditions and dropped back behind me, and I simply outturned them. I don't think you can help but look at this airplane and have a reaction to the cleanliness of it and the sleekness of the lines and the flowing lines. It's striking in its appearance and it's striking in its performance. There's a cliche amongst the aircraft designers. I think Marcel Dassault was the first to say that if an airplane looks good, it'll fly good. And this airplane looks good, and I can assure you it flies good.
Its airframe design is truly revolutionary. The ATF has greater cruise efficiency and superior handling characteristics compared to most of today's fighters. Fiber optics, advanced aerodynamic designs, and digital flight controls contribute to the increased flight capabilities. The airframe is lighter because of extensive use of high-strength, low-weight composite materials. The ATF engines propel the 21st century fighter at supersonic cruise speeds without using afterburners, a revolutionary capability known as Super Cruise. ATF engines also have two-dimensional convergent revolutionary maneuverability, and are able to vector thrust to 20 degrees. As with the airframe, they employ advanced composite materials for engine components, which allow temperature tolerance increases from 1600 to an incredible 2500 degrees Fahrenheit. These, together with new forgings for blade discs called blisks that are lighter and stronger than conventional discs, contribute great strength and durability to the engines with a minimal weight penalty, crucial to the high thrust-to-weight ratio needed for supercruise. Spurred on by advanced compressors, combustors, fans, and extremely high-temperature lubricants, the ATF power plants have no equal or anything that approaches their phenomenal capabilities. As for weapons, the Advanced Tactical Fighter carries a full complement of medium and short-range air-to-air armament, including the AIM-120 Advanced Medium Range Air-to-Air Missile, or AMRAAM, and the AM-9 Sidewinder. Unlike today's fighters, which carry their missiles externally on their wingtips, under their wings and fuselages, ATF weapons are carried internally by a system that is highly classified and can be launched from revolutionary weapon racks which are hydraulically operated. The ATF is also equipped with a proven design internal gun and air-to-ground missiles. The ATF has been in demonstration validation, or what the Air Force calls DEMVAL, from October 1986 to the beginning of 1991. This phase served to generate as much information as possible to demonstrate the feasibility and capability of the technology. Demonstration validation reduced the risk of the next phase of the program, full-scale development. This was scheduled to begin in the summer of 1991. The demonstration validation phase included the objective of successfully balancing capability with cost. Affordability is a key consideration. The ATF developers work to achieve the most cost-effective weapon system which defeats the increasing threat to our air superiority capabilities.
The two aircraft you see here, or you've seen in action in the flying prototypes, I think are an excellent demonstration of exactly what we were trying to accomplish with this demonstration validation front end and the prototyping and hardware demonstration, including the avionics test beds that went along with that. We ended up with two aircraft, each one of which could meet the Air Force's technical specifications and technical requirements. And that's why, as I said in the formal remarks, that we had here a set of proposals or a set of contract options, any one of which was in the acceptable range and any one of which could have been selected. So we were dealing with shades of differences, given that all of the proposals were in the acceptable range. We had to make the evaluation based on the criteria that were called out in the RFP, and we've done that, and the best I can do for you today is to report the final judgment of that process.
To meet the stringent requirements set by the two military services, each of the competing prototypes feature low radar, low infrared, and low visual signatures, stealth technology, and both employ blended wing body design, man-made composition, to replace weaker, heavier metal. One striking example of the advanced technology employed is the fact that ATF prototypes have supercruised, supersonic speed without afterburner, at speeds in excess of Mach 1.5 or 1.5 times the speed of sound, outdistancing F-15 Eagle chase planes which use their afterburners. This feature alone extends the ATF's range and enhances its survivability. Both ATF contenders have undergone exhaustive tests and trials, including the weapons firing, over the past 5 years. And the YF-22 has demonstrated a spectacular anti-spin device. And the payoff has just taken place. The Air Force has made its choice of the manufacturer team and the engine producer that gets the full-scale development or engineering and manufacturing contracts. 2 months after the Desert Storm victory, on April 23, 1991, Air Force Secretary Donald B. Rice announced the multi-billion-dollar fighter airframe and engine decision for 648 to 750 aircraft.
The DEMVAL phase has accomplished the risk reduction and the design trade-offs that are its purpose. Its success is demonstrable in the excellent performance of the prototypes and the quality of the proposals from the contractor teams. To ensure the fairest possible evaluation of these outstanding designs and development teams, the evaluation process that we've been through has been intensive, thorough, and professional. That evaluation was conducted by Air Force and Navy teams, by a team involving both Air Force and Navy personnel, included not only the developer community, but users, testers, contracts experts, cost analysts, and all who would be involved in the next phase of development. The success of the demonstration validation phase and this formal evaluation process is also demonstrated by the fact that the evaluators were able to bring to me as the source selection authority 4 awardable contracts, each of which represented acceptable proposals that met Air Force requirements. However, in evaluating the engine and airframe proposals, one combination clearly offered better capability with lower cost, thereby providing the Air Force with a true best value. With all that said, I now announce that the ATF team will be composed of the Pratt & Whitney company who designed the F-119 engine, which will be integrated into the F-22, designed by Lockheed, team with Boeing and General Dynamics.
The Advanced Tactical Fighter represents the greatest advancements in aerospace technology since the invention of the jet engine and rocket propulsion.